In this video, we're going to look at direct variation in linear equations. It's number 7 in the series on linear equations and graphing. It goes along with an algebra class that you'd take in high school. If you want to see the rest of the playlist, check the description of this video. Let's begin with terms. First of all, what is direct variation? Well, direct variation is generally when one variable changes directly with another variable. One goes up, the other one goes up, or one goes up and the other one goes down. The constant of variation is the k that you see in the equation up here, y equals kx. It's also called a constant of proportionality, and if you graph the line, it will be the slope of the line. It tells you how much one variable increases as the other increases, or one variable increases as the other decreases. It can be positive or negative. In a direct variation, one quantity increases as another increases, or increases as another decreases, as I said. Graphs of these functions always pass through the origin 0, 0. You can prove it to yourself right now. Take a look at the equation. If I plug in 0 for x, anything times 0 is 0, yeah? So if x is 0, y is 0. Here's an example. If we graph the equation y equals 2x, I suggest you make a table. You need 2 points for a line. So let's follow the standard and pick values for x and then plug them into the equation to solve for y. I have no desire to complicate this. So I'm just going to pick x is 0 and x is 1. First, for x equals 0, y equals 2x. That's our equation right here. Substitute in 0 for x. So y equals 2 times 0, which is 0. And then for x equals 1, substitute in the 1 for x in the equation. So y equals 2x. Replace the x with a 1, multiply, and you get y equals 2. So here's your table. You got your 2 points, 0, 0, and 1, 2. Then you can put them on a graph like this. Check it out, 0, 0. And then about here would be 1. It's halfway between the 0 and the 2. And here's 2. Draw a line between the 2 points, and you're good. All right, so like it says, now you do it. In a couple seconds, I'm going to be quiet and count to 5. You can pause the video and practice yourself if you wish, and then I'll pick it up. All right, ready? Go. Okay, here's how you do it. Pick 2 points. I'll pick x equals 0, and I will substitute in 0 for x in the equation. So I get y equals negative 3 times 0, which is 0. My first point is 0, 0. From a second point, I'm going to pick x equals 1. So y equals negative 3x. Negative 3 times 1, which is negative 3. Now, be careful. I mean, read the directions of your problem. You may have to pick certain points for this. I'm just picking 0 and 1 because it's easy and I don't have any particular criteria. Do what the directions say. Here's your table. Your points are 0, 0, and 1, negative 3. Here's the graph. Plot 1 point here at 0, 0, 1 point here at 1, negative 3. And then draw the line, and you're done. Something else you ought to be able to do is if I give you an equation, or if anybody gives you an equation, you ought to be able to find the constant of variation k. Fortunately, this isn't very hard because the constant of variation is also the slope of the line. First, let's read the points. Here's my graph over here. I have 0, 0, and I have 1, 2. Now, to get the constant of variation, I'm going to use the slope formula. You can do that when x and y display direct variation. I mean, you can use the slope formula with 2 points anytime as long as the line is straight. But slope is the constant of variation, though, when we have direct variation. Anyway, slope of a line is y2 minus y1 over x2 minus x1. I picked 1, 2 as x2, y2 and 0, 0 as x1, y1. I like to pick the point further to the right as being x2, y2 because it's more sensible to me. So, plugging them in. y2 is 2, y1 is 0, x2 is 1, x1 is 0. That gives you 2 over 1, which is a slope of 2. So the constant of variation k is 2, and we can write the equation y equals 2x. Now you try it. Here I gave you a couple points. I'm trying to make an equation of the form y equals kx. So in a minute I'm going to shut up, count to 5, let you pause the video, and do the problem. Ready, set, go. Okay, let's continue. The points are 2, 6, and 5, 15. So first this one. It's on the 2 line for x and the 6 line for y. And then this one. It's on the 5 line for x and the 15 line for y. I'm going to plug them into the slope formula. I picked 2, 6 as x1, y1, and 5, 15 as x2, y2 because 2, 6 is further to the left. So I got 15 minus 6 over 5 minus 2. That gives me 9 over 3, which is 3. So the constant of variation is 3, and the equation I can write is y equals 3x. Finally here, let's write a direct variation equation ourselves if we're just given values of y and x. So assume that y is 16 and x is 4. Let's write a direct variation equation that relates these two. And you have to be told that y and x vary directly in order to do this. It's going to take the form y equals kx. So let's just plug the values into that equation and solve for k. If y is 16, I'd write 16 equals k times 4. Divide both sides by 4. 16 over 4 is 4 equals k. So, equation we're going to write is y equals 4x. Don't get confused. Just because x is 4 and it looks like k times 4 here, that doesn't mean you can write 4 for k. You have to solve for it first. Try it yourself. Assume that x and y vary directly and y equals 42 when x equals 6. I will be quiet and let you do it. Go ahead. All right, let's continue. So we're plugging into the equation y equals kx. 42 equals k times 6. Divide both sides by 6. 42 over 6 is 7. 7 is our constant of variation k. So the equation we're going to write is y equals 7x. And that's it. That's the basics of direct variation with linear equations. If you like the video, please hit like. If you want more, go ahead and subscribe. And if you have any questions, put them in the comments. I'll get to them once I notice. Thanks for watching, and good luck with your math.